Starting with the corollary 2 of the Stokes theorem, if f vector be any continuously differentiable vector point function and S is a surface bounded by the curve C, then we need to show this result where the unit normal vector n at any point of S is drawn in the sense in which a right-handed screw would move in the sense of description of C. Please note this remark that the curl of cross product of two vectors is equal to the first vector into the divergence of the second vector minus dot product of first vector with del operator into this second vector. Right? I'm going to use this result in the proof. To show this result, I need to take a constant vector, that is a vector, and I have to take the dot product of this vector to the left hand side of this result, right? And then I'm going to apply the Stokes theorem to prove this complete result. So let's move on to the proof now. So let's take a constant vector, that is a vector, be any constant vector. Writing the left hand side of the result, that is a line integral over C, f vector is cross product with dr vector. And I have to take the dot product of a vector with this integral. Because this is your constant vector, we can write this further as I'm taking this vector inside this integral with this dot. So this is a vector dot product with f vector cross product dr vector over the curve C. In the next step, shifting this cross to this dot and this dot to this cross. Because I need to apply the Stokes theorem, so I'm writing here a vector cross product with f vector dot product with dr vector and taking this in bracket. And now we apply the Stokes theorem over here. So this is our function now. So by Stokes theorem, what is the Stokes theorem? It is the line integral over the curve C, dot product of f vector with dr vector is equal to the surface integral of curl of this f vector dot product with n vector ds. So replacing this f vector with a vector cross product with f vector. So using this theorem further, we write that this line integral is equal to the surface integral of curl of, that is cross product of a vector and f vector, and its dot product with n vector ds. Very fine? Okay. So writing this in the next step, I'm applying the Stokes theorem over here now. So this is further equal to the surface integral of curl of this vector and its dot product with n vector ds. So this is equal to the surface integral of, I can write this curl to be as del cross a vector cross f vector. Right? And the dot product with n vector ds. Let's move on to the remark. Now I'm having the curl of these two vectors. What is the curl of these two vectors? Let's move on to the remark. This one, the curl of these two vectors is equal to the first vector, divergence of the second vector, minus dot product of first vector with del operator into the second vector. So using this result now, so this is equal to the surface integral of, the curl of cross product of two vectors. So writing here, first vector into the divergence of the second vector minus dot product of first vector with del operator multiplied with the second vector, and writing rest of this, that is dot product of n vector ds. Taking this dot product of, let's take the dot product with n vector with both the terms inside the bracket. Very fine. Okay. Now dot product of this divergence of f vector cannot be taken with this n vector. It cannot be possible. So we need to shift this dot at this place. So this is surface integral of a vector taking its dot product with the divergence of f vector, and this divergence of f vector is multiplied with this n vector minus taking these two in bracket. And now I need to take this a vector common from these two terms. This is our constant vector with its dot product. So this is a vector having its dot product with this complete surface integral. What is on the left hand side? It is a vector dot product with the line integral of cross product of f vector with dr vector. And now let's take this complete right hand side to this left hand side. And in the next step, I'm taking this a vector common from these two integrals with its dot product. And because a vector is a constant vector, it is arbitrary and it is having its dot product with these two terms in the bracket. So this implies what? From this we can say that this complete terms in the bracket is equal to 0. Yes. So writing this. But a vector was arbitrary and it is having its dot product with these two terms to be equal to 0. So this implies the complete terms in the bracket is equal to 0. Taking this surface integral to the right hand side, so this implies the line integral of cross product of f vector with dr vector is equal to the surface integral of divergence of f vector multiplied with n vector minus del operator into the dot product of f vector with n vector ds. So we have shown this line integral is equal to this surface integral. So this is the second corollary of the Stokes theorem. Okay, thank you.